My name is Phyllis Newbill. I work with the Center for Educational Networks and Impacts, which is one of several centers within the Institute for Creativity, Arts, and Technology. This morning we are already live streaming the Playdate, and so the questions that you ask at the end of the Playdate will exist on the internet immediately and afterwards, so behave accordingly for there. There is a sign-in sheet rolling around on a clipboard, so I would hope that you all sign in so that allows us to justify our donut purchase and coffee purchase, so make sure that you sign in. If you have questions online, good morning to those who are watching online. If you have questions there's a questions link on the event page and also on the YouTube. Send us a note and we'll get that and get your questions asked as quick as we can. If Professional Development Network or PDN credit is helpful to you as a Virginia Tech faculty member, make sure that you register for that and also make eye contact with me and make sure that I have given you such credit. Announcements this morning, mini seed grants. Please check the ICAT website for all the details about this, but the mini seed grants are due next Friday, so 1 week from today. The major seed grants, are the larger ones, are due, I wrote down the wrong day, due February 27th, 4th, February 4th. Okay, I did write down the right day. It's due February 4th. Make sure you're ready for that. That's coming really soon. Okay, that's good. So, good morning, and this morning we have Doug Bowman, who is the director of the Center for Human-Computer Interaction, which is another center within ICAT, talking to us about how AR and AI are going to transform the personal computer. And this is a topic for everybody. Like, people are talking about this everywhere. And if you actually want to know what is going to happen with it, this is the guy to ask.
Wow. Good morning. I definitely don't know if I can live up to that last bit that Phyllis said. I can tell you what I think, but your mileage may vary. So as Phyllis said, I'm Doug Bowman. I am in the computer science department and also director of the Center for HCI. I'm not talking about CHCI this morning, but if any of you are interested to learn more about the center and what we do and how to get involved, please talk to me or to Andrea up here. We'd be happy to tell you more about that. But I want to spend a few minutes this morning talking about some of our projects and thoughts about the future involving augmented reality. And I want to start with this kind of broad strokes overview of how general purpose computing has evolved. And I'm not a computer historian, so if you are, please forgive me for the simplicity of this. But you know, the first kind of general purpose computers were all mainframes, right? Large computers that were centralized that nobody had personal direct access to, so they certainly weren't personal, and people didn't have individual control over them, so they were a bit unsatisfactory in that way. And so then, of course, we moved to personal computers, PCs, but you know, these had many limitations as well, especially in terms of portability, right? So you could only use them in one location. So then we got laptops and similar sorts of devices, which made them personal and portable, but still not always convenient, right? You can't use a laptop everywhere. It's hard to use a laptop on the beach, despite what some computer ads at the time might have told you. And so finally, of course, we evolved to these computers that we carry around in our pockets all the time. So all of us have general purpose computers that are personal and portable and convenient, but still have limitations, especially on the interface side, and in particular, the size of the display, right? So it's hard to do kind of all your general purpose computing just on a smartphone, although I think some of you probably try. And it's important to note that these didn't replace each other, right? All of these sorts of computing have continued. We still have big server rooms, right? People still used non-portable PCs and laptops and so on. But the question that I really want to talk about is what's coming next? What's the next evolution that solves maybe some of these limitations of the smartphone? And my thesis here, my hypothesis, is that AR glasses are the thing that will be the next evolution of general purpose computing. So they're still personal, right? They're more personal than any of those other devices. They're worn on your face, literally. No one else can see the display, so they're private as well. They're fully portable. They can be used anywhere eyeglasses can be worn. So unless you're swimming in the ocean or maybe asleep on your pillow, you can use AR glasses. They're highly convenient because they're always available. They're on you, right? And they're always in view. You don't have to look somewhere special to see the display. And talking about the display, their interface, their display is unconstrained, right? With AR glasses, we can put virtual displays anywhere. They can be any size, they can be any shape, they can be any location. And I should clarify that I'm not talking about kind of the typical, what you might think of as smart glasses, like Google Glass, right? Those don't have the capability to track where they are in space, and so they can't put virtual displays registered to the real world. They can only give you a little floating window at one part of your field of view. So true AR glasses, like the Apple Vision Pro that's, I guess you can pre-order today, hopefully you got your pre-order in already, will allow you to put any size, shape of display anywhere you want in the world and have it appear to be part of the world, as this image shows. Okay, so here's some current AR technology. I already mentioned the Apple Vision Pro there in the middle. Things like the HoloLens 2 has been around for a couple of years. The Vario XR3 is a fairly new high-end video see-through device. So if you look at these, they all kind of have one thing in common. They're not things that you would want to wear all day, right? They're still big, they're bulky, they're expensive. Apple is selling the Vision Pro for $3,500, I think, which is probably not something that all consumers are going to want to get in on right away. So they're not where we want them to be, but the vision is of something called everyday AR. And everyday AR is where we have virtual displays that are available all the time and anywhere. They contain information and applications that users need anytime. Users interact with these virtual displays for all their general purpose computing needs. And the displays, as I said, are registered in the 3D physical world. And when I say virtual display, I mean it could be like a simulated monitor, right? Or a virtual smartphone. It could just be an application or a window or a document that's there in space. Or it could be a 3D object or scene. So any of these sorts of things. But the important point is that for everyday AR to exist, we really need all-day AR glasses, which we don't currently have. So these all-day AR glasses would need to be just like the eyeglasses that many of you are wearing right now, right? They'd need to be lightweight. They'd need to have the eyeglass form factor, or maybe even contact lens form factor. They need to have an all-day battery, so powerful. They need to not have any cables or tethers. They should have a wide field of view, a high resolution, and probably need eye tracking for interaction and for understanding what the user is doing. Okay, so we don't have these yet. Lots of smart people, not me, are working on them. I think they're coming. And so the question is, what can we do once we have these all-day AR glasses, and what should the experience look like? So in my lab, we've done a bunch of prototypes using current technology to try to explore what this world might be. And so one of the very first things we did, it was very obvious. We just tried to replace physical computer monitors with virtual computer monitors. And so this is a prototype using the HoloLens, where my student Leo now has 3 very large virtual monitors that are around his desk, and he's running real Microsoft Windows and real applications on here using his regular mouse and keyboard, but he has no physical monitor. Okay, so that's kind of cool. We can also do this in a hybrid way, so there's still some advantages of physical monitors. They have better resolution still than AR glasses, people are used to them, they're familiar, so we can use one physical monitor and then a couple of virtual monitors for peripheral sorts of tasks. And in general, we've kind of explored how we can use these virtual monitors for more flexible computing space, more flexible display space. And these are some illustrations of different ways that you might want to configure virtual screens. So they could be flat, they could be curved. They could be surrounding you, they could be just extensions of a physical monitor. You could have different sizes and shapes of virtual monitors all at the same time, and they could adapt to different tasks that you're doing. Here's a few more prototypes that we did. So the ones on the left, the ones on the top row are showing kind of just a replication of a 6-monitor setup. So some of you might have multiple physical monitors in your offices or home offices right now. So not many people have 6, but some do. So we replicated that with virtual monitors in both a completely virtual and a hybrid way. And then on the bottom are a couple where we said, okay, we don't actually need to have these boundaries between screens like we do with physical monitors. So instead, we could just create a huge canvas, right? A very, very high resolution and very large space with no boundaries where we can flexibly put content and applications. Okay, so we don't need to just do this on the desktop or in our offices, right? We could also think about how to use AR virtual displays on the go in mobile situations. And so we've done a bunch of work on a concept that we call glanceable AR. Glanceable AR means that you have information or applications that follow you as you move through the world. You have rapid access to all that information and applications, but at the same time, it's supposed to be unobtrusive, non-distracting, non-occluding. Think about it if you had, all of your applications floating in front of you all the time as you walk through the world. It would not only be distracting, it would be dangerous, right? You would walk out in front of a bus or something. So the question is, how do we do that? And we do that in our approach by having body-fixed content. So we don't fix the applications to your head. Instead, we fix them to your body. And we place them mostly outside the field of view in the periphery. So your front view is clear, it's non-occluded, and you have applications and information off to the side, and you can glance at it as needed. So here's a super simple video that shows the basic idea. This is from several years ago. We're walking down the hall in the Moss Arts Center. There's nothing in our view. We can turn to the right and see what the current news story is. Okay, so that's the basic idea of glanceable AR. So since that time, we've done a bunch of prototypes. And this is a quick video. Well, it's actually not too quick, but a video of some of our most recent prototype that we showed. And so my student, Fei Yu, did a really interesting system where he's got 7 different apps. So he's got a calendar app, a news app, a to-do app, an email app, etc. And all of these are gathering real data in real time from the internet and from your own personal Google account. And you can place these apps either fixed in the world, or you can have them body fixed, as I was talking about before, so that they move with you as you walk along. And then he worked really hard on different interactions. And our goal was to try to do all interaction with these glanceable AR apps only using your eyes. And so that's a pretty tall order. So he uses a bunch of different techniques. So one technique is dwell, where you stare at an icon or a button for 1 second in order to activate it. There's a blinking technique where you can do a double blink in order to activate a control. And there's several other ways that we use eyes to activate and to interact with this information. So we did a bunch of studies with this, and here are some of the really high-level findings. Morning, Gio. So one is that users prefer to see the real world by default, as you might expect, right? So we don't always want to be interacting with this glanceable information. So again, the front view by default should be clear. And I also really like the idea that Magic Leap had a few years ago, where they actually have a physical button on their device that's labeled reality. And when you press that button, the display goes blank so that you only see the real world. Second, people are willing to use glanceable AR in authentic scenarios and find it less distracting than smartphones. This was actually kind of surprising to us, right? Because we have been focusing on how to interact with all this information. It turns out that when people use it in the real world, they mostly don't look at it until they need it. And when they do need it, they can access the information in glanceable AR actually faster than they can pull out their phone and access the same information. And then finally, moving information to the periphery or just minimizing it visually so it's a transparent icon is effective for reducing inclusion of the real world. We found that people could move through the real world and do tasks that involve real world objects with this system on by using these techniques. Okay, so I promised that we were actually going to talk about AR+AI, and so far I haven't talked about AI at all. Why do we need something beyond what I've been describing? Well, I think there's a couple of reasons. One is that In our current glanceable AR prototype, there are a lot of different settings. You can change the way that you interact with your eyes. You can change where apps are located. You can change whether those apps are world fixed or body fixed. There's a lot of settings that you have to fiddle with, and you fiddle with them a lot when you move from place to place or you're doing different things. In other words, you're in a different context in the real world. We think that shouldn't have to be done manually. Secondly, there's a huge amount of information out there. Duh, right? Millions and millions of documents, files, websites, et cetera, that you might want to access through your AR glasses. I don't think we want to be spending our time manually searching and browsing when we're in the real world, talking to people, doing real world tasks. Instead, there should be some sort of intelligent automation there, and it should be context-based. So the idea of intelligent AR is that, first of all, we can sense contextual data. We can use the sensors on the AR headset, like cameras or depth cameras or eye trackers or microphones. We can also just use available information in databases, like characteristics of this user or characteristics of this location, right? From that data, we can then infer what the context is using AI, using computer vision and machine learning models. We could say, what is the current environment the user is in? What task are they doing? Who's around them? Who is this person and what do they care about, right? Based on that inference, we can then adapt both the interface and what information is displayed. So we can make the interface work in a way that's appropriate for the context, and we can show the user information that they're likely to need when they're in that context. So let me show a couple of examples real quick. This is a very simple example here. So this is back to our kind of virtual monitors work. And so we have this prototype where we can place windows in different slots around kind of a physical monitor. And when the system senses that the user is looking at one of these virtual windows, it can enlarge and move the other ones out of the way, right? So that's a very simple kind of intelligent adaptation based on context information. Here's another one. You may have seen this in the previous video, but this is the idea that apps can change the way that they're displayed based on the depth at which the user is gazing. So again, using the eye tracker. In this case, if the user is looking out the window at the real world outside, then the app is minimized. But if they change their depth of focus to look at this little icon, then the app shows more and more information, in this case about the weather. Okay, and then here's the final one, which is a little bit more complicated. We would love it if the system could sense when you were having a conversation with someone and adapt its display automatically. So let me see if this video works. Oh, I don't hear the sound, but I can describe what's going on. So they're having a conversation, and we're seeing the user's view of the conversation partner here. And the system senses not only that there's a person in view, but also what they're talking about. It listens to the content of the conversation. And in this case, they're talking about exercise. So the exercise app then appears, but it doesn't appear in the center of your view. It actually appears up higher so that it doesn't block the conversation partner's face. So that's another sort of context-aware adaptation. So what could this sort of intelligent AR do in the future? So here's just a few examples. So maybe it can sense what room of your house you're in. So when you go to the living room, it predicts you're going to use the Netflix app and brings it up for you automatically. But when you go into the kitchen, maybe it predicts you're going to use the shopping list app. It could display information in different forms depending on what's going on. So it could display text information when you're stationary, but change that information to audio representation when you're moving. It's another intelligent adaptation. Thirdly, maybe it would switch from gesture input to voice input when you're doing a real-world task that involves both your hands, right? So it senses what you're doing with your hands and automatically adapts the interface. And then maybe the most complicated one here, let's say you walk into a conference room at a scheduled meeting time that's on your calendar, so the system knows to automatically open the meeting agenda for you. Not only that, it senses that there are other people in the room who are also supposed to be in the meeting and shares that information with them with their AR glasses and places it on the wall so that everybody can see conveniently the agenda at the same time. Wouldn't that be cool? Yes, it would be cool. All right. So to wrap up, a couple of kind of thoughts about how to use AR and AI to enable future personal computing. So if our goal is to use AR to work within real-world contexts without clutter or distraction, the thought is that we can design AR interfaces that allow rapid access and automatically keep the content out of the way from the real world. If we want to assist the user by providing the right information at the right time in the right way, the approach is to use context awareness, right? To understand the user's environment and task, to intelligently adapt what they're seeing and how they access it. And if the goal is to improve on current computing experiences, not just to replicate them, we can take advantage of the flexibility of these AR virtual displays to do that. Final thing I'll say is that this is an ICAT Playdate, and so I have to make clear that this is not just a computer science project, right? Or even just an HCI project. It really requires this kind of interdisciplinary work from artists and designers and engineers and people who do user experience and human factors and probably more that I haven't listed here. So all of you could be involved in work like this. Okay, I want to acknowledge my students and my collaborators and my funding agencies, but thanks for your attention and happy to take your questions.
Thanks so much, Doug. That was, as always, envisioning the future in new ways because I'm at an ICAT Playdate. What questions do we have, either in the room or online? I have several, but.
Thanks, Doug. This is like super interesting and a little scary also. What about the idea of obscuring information? So here's a case example. At the supermarket, I'm looking for the product that I always get, but they're constantly moving it around. There's a million choices. I would just like to find what I want and move on. Could you, so the examples that you gave were a lot about adding information to people's periphery, to people's viewshed. What about subtracting information?
Yeah, great question. So, I mean, I could take that in a couple of different directions. I think what you're asking about is a concept called diminished reality. So augmented reality is the idea of adding, really, of augmenting what you see. But there's this sister concept of diminished reality, which means exactly what you said. So blurring things out, obscuring them, blocking them if they're irrelevant to what you're doing so that you can stay focused. And so I think that's it's been certainly less studied than augmented reality, but that's certainly an important part of this future. But then when you said obscuring, this is not what you were asking, but it also made me think about kind of obscuring things for privacy reasons, right? So a system like this would first of all be collecting a lot of data about you and your activities. And so we have to be very careful about where that data goes. Does it go off the device? Who has access to it? And so on. Brendan David John, who's one of my colleagues in CS, is working a lot on AR and privacy for things like that. Including the issue of not only my own data's privacy, but also the privacy of the people around me. So if I have on these AR glasses and my glasses are sensing who's in the room, you know, that's a privacy sort of issue as well. So if that data goes off the device, maybe I need to like blur out the faces of everyone in the room before it goes or something like that. So lots of interesting issues there.
Hi, Doug. Thanks. This is super interesting. So we've kind of had the promise of like AR glasses for a really long time, ever since Microsoft released the original HoloLens. What do you see in your experience? You are deep in human-computer interaction. In your experience, what do you see as the biggest barriers to everyday AR glasses, whether it's hardware, computing, network infrastructure, et cetera?
Yes, all of those things. I mean, it's a super hard engineering problem. Like I said, there have been a lot of smart people working to try to achieve this just from a hardware perspective for a really long time, and we're not there yet. So, I mean, that tells you that, you know, it's non-trivial to do this. It's not just a matter of throwing more money at it. So, I mean, there's just a lot of, like, constraints in physics about, you know, how optics work and how big things need to be and how much power it requires and where the heat is going to go and so on. I'm not an expert on any of those things. I trust that smart people are going to figure it out, but I can't, that's why I can't really give a timeline for when these glasses are going to be there. I think that's obviously what Apple would like to do and other companies similar to that, but I don't know. I mean, I think the fact that Apple is releasing this Vision Pro today in its current form factor means that it's at least still several years before we could achieve a more wearable and acceptable form factor.
So we've got a question online. What steps will be taken to ensure the privacy of other people? Like what happens if someone was trying to secretly record other people while wearing AR glasses? You covered that a little bit.
Yeah, I mentioned that a little bit before, and I mentioned Google Glass in my talk. That was one of the biggest things that maybe led to the downfall of Google Glass is that people who were not wearing them saw people wearing them and thought, I don't know what that's doing, and I don't want it to do what it might be doing, right? So it has to be very clear, both to the user and to bystanders, what's going on, what data is being collected, how that data is being used, where it's going, and so on. And again, I would refer you to Brendan David John's work. He's doing a lot of interesting stuff in that area.
So in addition to one of the questions asked about like that diminishing aspect, I'm thinking about like cognitive load. We know that a lot of information are trying to go from multiple tasks really quickly doesn't necessarily work. So expanding and providing more of this information, I think, might actually have probably more of a detriment sometimes on task and performance. Have anyone been looking into that, and like how does that come into play?
Yeah, great question. So we care about that a lot, and one of our goals throughout all of our work, especially in the glanceable AR work, has been for it to be a calm computing experience. So that's why, again, our default view is that you see nothing besides the real world, right? You only get information access when you kind of explicitly ask for it by turning your head or by focusing your eyes in a certain way. And then the idea of adding intelligent prediction of what information you'll need is also intended to address this problem, right? So if I have to, flip through, all of my stored files in order to find the one that I want, that can be overwhelming. But if the system can say, if I can say I want to see a document right now, and the system gives me 5 choices of the documents that I'm most likely to need right now, then that's much calmer, right, and easier, less cognitive load, maybe less information overload. So I think that's a super important part of this vision.
Yeah, so this is probably a pretty fundamental question, but I'm just wondering about like how eyes focus. Like if I'm looking at you, my eyes are focused far away from me, so I wouldn't be able to see anything in augmented reality. So I'm just wondering, like, what's the kind of limit? Like how far out can we put things?
Yeah, that's a really good question. So almost all current augmented reality displays have a fixed focal distance. So the virtual content, at least from the point of view of your eye's accommodation, the way your lens in your eye focuses, is at a fixed distance, like 1.5 meters or 2 meters. And so anything that's closer than that, that's in the real world, or farther than that in the real world, if you focus on that, then the AR content is going to be blurry, right? There is work, and there's at least one commercial device that has multiple virtual focal planes, so that it can adapt to where your eyes are looking, and so things can stay in focus all the time. But that's still an open research area as well.
I'll come to you.
Maybe going back to your answer to the question that came in online about disclosure of what someone is looking at. I think about a tweet that I saw years ago that said, "How I know you care about me when we're out at dinner together, I never, never, never see your phone," right? And I'm thinking about this scenario in the future where 2 people are having a conversation, both of them have AR glasses on, and they're not actually paying attention to each other at all, right? We've got other things going on. So what does that scenario look like in the future in terms of human connection and intimacy, right? Is there this moment where, like, how I know you care about me is you take your AR glasses off, right? We have a no glasses conversation. Or what does that disclosure look like to the other person in a conversation?
Yeah, good question. There's lots of parts to that. So one answer is, that's why we did this prototype with the conversation that I went through really quickly. If people are wearing these AR glasses, we want it to be aware of the fact that you're trying to make a human connection and to get out of the way, right? So the default, when it detects that you're having a conversation, is that all of your content goes away, it minimizes, it becomes transparent, whatever. And it only displays content when it picks up on something in the conversation to which that content is relevant. So if I'm having a conversation with my wife at dinner about our kids and their sports schedules, I am going to pull out my phone, and that's appropriate, right, in the context of that conversation. to do that. And so we want to display information only when it's appropriate. That's one answer. In terms of the disclosure question, I mean, there's going to be a transition period where some people have AR glasses and others don't, and I think that's hard. Once we get to the point where 90, 95%, 99% of people, like today, they have smartphones. In the future, will have AR glasses. Maybe it's a little bit easier because everybody kind of knows what to expect because they've experienced it themselves. But there'll have to be some kind of cultural conventions worked out, just like we've worked them out for smartphones. Yeah.
We are at our time, so thank you so much, Doug, for all of your answers and thoughts. Well, let's give you another round of applause. And thank you, all of you, for your questions. I know there may be some more questions in the room, and I know there were a few more online. I'll forward those to you. Next week, we'll be back here in the same time, same place with Pinckney Benedict, and we'll be talking about AI and creative writing. So the conversation continues, and thank you all. Have a great weekend.